Bam, Mr. Taru. Okay, we just did a video of helping you understand the polar coordinate system, or attempting to. Hopefully that helped. If not, let me know what you still need to still need me to go over. Right now we're just going to do a quick video of converting between rectangular to polar and vice versa from polar to rectangular. Going from polar to rectangular is a lot less work and doesn't require nearly as much thought if you're just using your calculator to get these answers. However, from rectangular to polar, and I'm going to repeat the first example from the last video, takes some thought. Okay, if you want a polar coordinate, you need an r and a theta. So, r is equal to the square root. Now my point down here is going to be negative 12, negative 5, which is in quadrant 3. So we have negative 12 squared plus negative 5 squared, and that comes out to be the square root of, let's put it down here, the square root of 144 plus 25, which is the square root of 169, or 13 units. This point is 13 units away from the origin. X, y, and r are the hypotenuse. And you should know 5, 12, 13 is one of your Pythagorean triples. I'm just picking numbers that I can do relatively easy in my head. Now, as far as finding theta, as far as finding the amount of rotation that we must do from the positive side of the x-axis, if you will, because what else am I going to call it? How much do you have to rotate before you get the pointer, that theta, to go towards that coordinate of, well, right now, in rectangular form, negative 12, negative 5. Well, okay, we have x, we have y, we have r. We don't really need this formula that textbooks generally give us. For conversions, tangent of theta is equal to y over x. We've known that now for a couple of chapters. And when you know x, y, and r, you can use any trig function you want. Sine, cosine, tangent, secant, cosecant, if for some reason you want to use those. But this point is in quadrant 3, so the calculator, the value that comes out of our calculator is not going to be really very usable. Inverse sine only gives us answers between negative pi over 2 and positive pi over 2, or negative 90 and positive 90. Inverse cosine as an inverse trig function only gives us answers between 0 and pi. Inverse tangent, as our textbooks like to recommend that you use, again only gives answers between negative 90 and positive 90. So the fact that this is in quadrant 3 means that you are not going to get a usable angle measure out of the calculator. Well, it'll be usable, but it won't be the final answer. So let's go ahead and stick with the tangent anyway. So the tangent of theta, which is equal to y over x, is going to be negative 5 over negative 12. Those, of course, cancel out. Theta is equal to the inverse tangent of 5/12, and the inverse tangent of 5/12 is equal to 22.6 degrees. Okay, great, except that's in quadrant 1. We need an angle in quadrant 3. And again, like your unit circle, how about the cosine of 45 degrees, or pi over 4, is square root of 2 over 2. And the cosine of 7 pi over 4 is square root of 2 over 2. And the reason why those have the same answer, the cosine of 45 and the cosine of 315, or the cosine of pi over 4 and the cosine of 7 pi over 4, is because they have the same reference angle. So we need an angle in quadrant 3 that has the same reference angle as this 22.6. I'm just using degrees because it's easier to do in my head. So the actual theta that we need is going to be pi, or excuse me, not radians, 180 degrees plus 22.6 degrees, or 202.6 degrees. If you were in radians, you'd be adding to pi. Now please, don't, with these questions, keep going, oh yeah, we just always add to 1 by 180 or 2 180, or we always add to pi, or we always subtract, or we always use 360 or 2 pi. Please draw a picture and look at where you're at. If you're in quadrant 2, it's going to be 180 minus your reference angle, or pi minus your reference angle. If you're in quadrant 2, again, now you've gone past the 180 or the pi, so you're going to add your reference angle. And if you're in quadrant 4, you're not going to reference pi or 180 at all. You're going to be looking at 360 or 2 pi. So draw a picture, let yourself see where that point is so you correctly find the angle measurement that you actually need. So my final answer, my final polar coordinate is going to be, well, instead of negative 12, negative 5, in polar form, it's going to be 13, 202.6 degrees. And now we can add 360, subtract 360, add 180, and make the radius negative. There's all kinds of things we can do to make other coordinates, other polar coordinates that describe that point in space. If you need help with that, watch my Understanding the Polar Coordinate System video. Okay, so negative 12, negative 5, at least one possible answer for a polar form is 13, 202.6. And I'm doing this video again, or this example, because I gave an answer. I gave a coordinate in quadrant 3, and that means the numbers out of our calculator are not going to be, they're going to be usable, but not the final answer for the angle measurement. So pay attention to that as you do these problems. All right? Let's do this example in reverse. What if, and we'll call it a day, what if we want to go from polar form to rectangular form? Well, let's just use these same points again. Why not? We know they work. We want to go from 13, 202.6, and we want the rectangular form of that same coordinate. We know it's negative 12, negative 5, but is it an issue, the fact that this point is in quadrant 3? Are the numbers out of the calculator going to be usable? Well, we have x, we have y, we have r at 202.6. We can use our basic understanding of trigonometry to find the x and the y coordinate, verify that it's actually still negative 12 and negative 5. You know, we have those skills, but when you do these conversions and you're looking at a new section in the textbook, the author can't just say, well, go back to chapter 4 and look that stuff up. So a little shortcut formula, x is equal to r cosine theta, and y is equal to r sine theta. Now, if I take this equation and I divide both sides by r, don't I get the cosine of theta is x over r? If I divide both sides by r, don't I get the sine of theta is y over r? Have we not known that now for a couple of chapters? So, no new formulas for these conversion problems. Okay, so this is r, this is theta. We want x and y, so x is going to be 13r times the cosine of theta, or 202.6. Make sure your calculator's in degree mode, or in radians if that's what your textbook is doing, but I'm in degrees. And that should come out to be, well, of course we know it's going to be roughly negative 12, and I've already rounded off in my scratch work, but it's going to be roughly negative 12. Now, why do I say roughly? Because, there's round off error. Did you take your decimal up to the 10th place? I don't know, 202.678, no, of course we rounded off a little bit. So it's going to be a little bit off due to round off error, but x is going to be negative 12. And y is going to be r sine theta, and that means that the y value out of your calculator is going to be effectively, and it depends on how much you've rounded off or did not round off, negative 5. So we've gone from polar to coordinate. Why is it we don't have to think about these values? But because the cosine graph is a function. The cosine of 0 is what? The cosine of 0 is 1. So the cosine graph, does this and it oscillates along the x-axis. That's a function. If you oscillate like this along the x-axis, you're going to pass the vertical line test. It is a function. So no matter what you put in there, whether it's 30 degrees, 150 degrees, 240 degrees, or 202.6 degrees, you are going to get that one answer that you need because the cosine graph is a function, and so is the sine graph or the sine function. They are functions. So whatever we get out of our calculator is going to be, of course, correct. That's not the case with your inverse functions. We have to restrict those answers so that it actually acts as a function. So again, inverse sine, your restricted values are only between positive 90 and negative 90. Inverse cosine only answer between 0 and pi. Inverse tangent only answer between negative pi over 2 or 90 and positive pi over 2. So that's your conversions. I'm Mr. True. Bam! Go do your homework.